Okay, I want to continue with our exponential models, but this time we're going to look at not just a simple exponential like would be seen in this graph, but one that has been shifted by adding a constant to the end. If I look at the difference between the red graph and the blue graph here, I can see that every single one of the blue points is exactly up 40 points. Since each of these grid lines is worth 10, it's up exactly 40 from the previous one, from the red. Okay, that value right there is 40 the whole time. All right, so that's what happens when I add a constant to an equation, is it just shifts the graph up or down that many units. So if I look at the two equations and some coordinates that they pass through, right, the red graph passes through 0, 1, 44. The blue graph is 40 points higher, 0, 184. And now I want to look at the written part of my equation. Okay, so this 144 is no longer the height above the x-axis, right? But to get the 184, if I were to add the 144 and the 40 together, that would give me my 184. Okay, in other words, this value right here is my y value, my 184, minus the 40 units of my shift. And what that's doing is telling me, if I draw in my shift, right, I moved everything on my graph up 40. So what this 184 minus 40 is telling me is how much above my shift am I? Okay, because that ratio of 3/4 only applies to the ratio of values of heights that is above my shift now. So each one of these bars above the shift, the height above the shift, will be 3/4 of the height of the previous bar. Okay, so when I have a shifted exponential, this rate, this 3/4, is relative to my shift. Okay, each one goes down by a quarter relative to my shift, not relative to the x-axis. So what that means is it helps me to write equations as I go about doing this. All right, so let's take a look at a scenario and see if we can make sense of what's happening. So let me describe a little bit. You know those motion sensors that we were using in class when we did the walking graphs? Well, I've got one of those sensors placed here. And over here, I have a pendulum. I have a pendulum that is swinging like this, back and forth. Okay? The resting position is here. And I do know that the distance from the motion sensor to the resting position of the string is 1.25 meters. Okay, so that distance is 1.25 meters. Now what's happening is I'm recording the swing number, and every 10 swings I record the distance measured from my sensor to the string on its furthest distance away. All right, so I'm measuring from this position right here in the pendulum. So at zero swings, that was 2.35 meters. Now, as it continues to swing, it starts to lose a little bit of that distance, right? So after 10 swings, the furthest it is away from the sensor is now 1.97. Okay, so that would be somewhere out here, right? It's no longer getting any further away from the sensor, all right, than this. And as the swing numbers continue to go, this number gets lower and lower and lower and lower. All right? So that's the situation that's going on. So because of friction and those kinds of things, the swing gets less and less over time. And initially it was 2.35 meters away. and the distance to the rest position from the sensor is 1.25 meters. So that's the situation we're in. So what I'd like to do is model with one pair of points, writing the equation. And so I've chosen these 2 points, from the table of values on the last slide. All right, so what I'm going to do is I'm going to do y minus the shift, okay? The shift is 1.25 units, that's the resting position. So y minus 1.25 is equal to y1 is the y value of the first coordinate, and x1 is the x value of the first coordinate, okay? I'm going to apply the shift both to the y and to the y1. So the 1.7 is 0.45 units above the 1.25 rest position. Okay, b is what I don't know. All right, and the second coordinate, the 30, 1.53, is an x, y value that I can use to substitute into this equation so that I can find what b is. So it takes 2 coordinates. So I'm going to plug in the 1.53 for y and the 30 for x. So, and I'm going to let you continue to do this. You're going to end up with b to the 10th is equal to this subtraction divided by 0.45, right? And then you'll undo raising of the to the 10th power using a 1/10 power and calculate the value of b. Once you've done it for this ordered pair, I'd like you to please do it for a different pair of ordered pairs. So pick 2 other values from that table of value and do this process again. And then what we're going to be looking to do is compare the values of b that you get. All right, so that's the general idea with the shifted exponential. So when we look at our models next time, we'll practice this in class, but when we're looking at it, we're going to be asking whether or not it is decaying to 0. If it's decaying to 0, I can use the regression feature on my calculator. And if it is decaying to some other value, then I need to use the shifted exponential. And we'll look at that more in class. Thanks.